Okay, in the second half of 1-5, we're going to deal with the more complicated inequalities where you've got, addition and subtraction as well as multiplication or division. Okay, so this first example right here, we are trying to get just an x by itself on one side of the inequality. That is your end goal. So basically, you just want to kind of look around and see what seems to be causing the most mayhem. What seems to be making it the most complicated? And I would say that it's this 5 in the denominator. That seems to be making one of the sides really complicated. So remember, you go for the opposite. We're being divided by 5, so you multiply by 5. You multiply this side by 5, and what happens is the division and the multiplication cancel each other out, but then you have to take the left-hand side and multiply it by 5. So let's recap. If we look up here, we are multiplying by a positive number, so our inequalities do not change. So it still stays less than or equal to. If you multiply or divide by a negative, then your inequality would flip. So I have 5 times negative 3x, and that gives me a negative 15x. And then my right-hand side is now much simpler. I just have the negative 4x plus 22. Okay, so next, remember, like I said, we want to try to get all the x's on one side. So I'm going to take this guy and I'm going to move it over to the left. So it's a negative 4x. The opposite would be a positive 4x. So whatever I do to the right, I do to the left to keep the balance. So these guys will cancel each other out. I have a negative 15x and a positive 4x. That leaves me with negative 11x. My symbol hasn't changed because addition does not change the symbol ever. And then I have 22. And then the last thing I'm going to do is get the x by itself. It's currently being multiplied by a negative 11, so the opposite would be to divide it by negative 11. Now be super careful here because this falls into this category. I am dividing by a negative number, so dividing by a negative number will flip my sign. So this is now a greater than or equal to. If this has the or equal to, so does this. That part will never change. And then all I have left is the x, and 22 divided by a negative 11 gives me a negative 2. So that's my answer in inequality form. I'm just going to graph it. So start with the 0. Negative 2 is over here to the left, where the negative numbers go. It's greater than or equal to, so since it has the or equal to, I'm going to shade in my circle. And then greater than means I shade to the right. Okay. Next one, we've got some distribution to do here. So the negative 5 gets distributed. Now, since I'm not doing anything back and forth, this negative doesn't affect anything. As long as you're simplifying things within one side, it's not going to mess with the inequality. So I distribute the negative 5, so I get negative 15d, and then negative 5 times negative 7 is a positive 35. Greater than, I haven't done anything that would change that symbol yet. Distribute the 3. 3 times 2d is 6d. And then 3 times positive 14 is positive 42. Okay, so next comes the addition and subtraction. Remember, I want to try to get the variables on one side and then the numbers on one side. I'm going to do this kind of all in one step. It's easier for my inequalities just to get the variable on the left, so I'm going to do that. So I'm going to move this 60 over by subtracting it from the right and from the left. So this cancels. Now I still have a number on the left-hand side that I want to move to the right-hand side. So I'm going to subtract this 35 from the left, and then I balance by subtracting it from the right. So now I have no more constants on the left. They're all on the right, and I have no more variables on the right because they're all on the left. So simplify this down. Negative 15d minus 6d leaves me with a negative 21d is greater than, and then I can subtract this right here, and I end up with 7. Okay, so now I want to get the d by itself, so I'm going to divide both sides by a negative 21. And again, be super, super careful. I'm dividing by a negative. When I divide by a negative, my symbol will flip every single time. So these cancel, and the d is now by itself. And then be careful here. A lot of people will want to tell me this is negative 3. It's not. The numerator is smaller, so it ends up being negative 1 over 3. Because these both have a 7, and I can reduce it down. So I get a negative 1/3. So again, this is my answer in inequality form. And let's graph on a number line. So show me the 0. Negative 1/3 is going to be like just barely to the left of it. Just a little bit negative. My symbol is less than. There's no or equal to, so I'm going to leave an open circle. And then for the first time, we're actually shading to the left here. So less than are all the numbers to the left. I always shade that arrow too to show that it goes on forever. Okay, So that's the second part of example 3. We've got one more example. This one's kind of an application problem. So Javier has $15 to spend today. So at most $15. That kind of starts to sound like an inequality problem. He buys a bag of pretzels and a bottle of juice for $1.59. If gasoline costs $2.89, how many gallons can Javier buy? Okay, so here's what we know. He definitely spent $1.59. And then he also wants to buy gasoline for $2.89 per gallon. So he could spend $2.89 per gallon. So I'm going to use a G for the variable. So however many gallons he gets, he just multiplies it by 2.89. And then we add on to that what we already know that he spent on food. Okay, it says he has at most $15. Okay, so this, what he's spending, it seems weird, but our symbol's actually going to be a less than, because what he's spending has to be less than what he has. He can't spend more than what he has. And then it's always a tricky question like, do I have the or equal to? Do I not have the or equal to? So he has at most $15 to spend. He could spend exactly $15 if the money worked out well like that. So we do have the or equal to, and then we've got $15 right here. So our goal, when he says how many gallons of gasoline, we're trying to solve for G. So really similar steps to what we just did on the previous examples. We want to start by subtracting $1.59. Okay, so cancels here. We still have 289G is less than or equal to. Okay, so when we subtract this, some of these decimals, I'm going to be okay with some of this work being done in your calculator. So we do 15 minus $1.59. So he's got $13.41 left for gas. So if you think about this in the context, what this means is he started with $15, he bought the pretzels and juice, and this is how much he has left for gas. So then if you divide by the price per gallon, that'll tell you how many gallons he can get. Okay, so you're dividing by a positive number, so the inequality won't change. So let's divide this. So 13.41, we want to divide by $2.89 to see how many gallons he can get. So the directions say round to the nearest tenth, so we're going to do 4.6. And since it's a story problem and there are units, you want to make sure that you include the units. So that would be your answer. He can get up to 4.6 gallons with the amount of money that he has left, but no more.